13.6 apply. It's easier than 13.5 in my opinion.
Yay.
That's not saying much.
But then you said this one was harder than the one before, so I don't believe you.
What?
Wait, there's a law of cosines.
I feel like we've met
Law of
this.
cosines is easier than law of sines in the sense that law of cosines only ever has one triangle.
Oh.
Yay!
Now, the actual law of cosines, like the formula, is mathematically harder
Aww.
than the law of sines, because law of sines is just sine of A over A, sine of B over B, blah, blah, blah. Well, the law of cosines says, if I can get my thing to work,
That's
That's a good L.
That's a really nice L. I can do
Thanks.
that too.
I think I was meant to have an L in my name
That
and
was
I
a
don't.
T.
Wait, let me try. Hang on.
If
The L from that church.
triangle, he said from triangle ABC
Looks like.
has side lengths. This is just a cursive L that I was taught when I was little.
Yeah, that's what mine looks like.
A, B, and C as shown. So I'm going to give you a triangle. Then I'm going to draw the triangle first. A squared equals B squared plus C squared minus 2BC cosine A.
So Pythagorean theorem minus 2 because A.
Well, it's
No.
not the Pythagorean theorem, but
It's
it looks like the Pythagorean theorem, yes, but it's not. B squared equals A squared, oh my gosh, stop, plus C squared minus 2AC cosine B. Or C squared equals A squared plus B squared minus 2AB cosine C.
These are a lot of letters.
No, it's not. It's a lot of words.
This is how I'm
Two.
So a note here, law of cosines only applies to the side angle side and side cases. So if you have side angle side, then whatever sides you're given and that angle go on the right side of this formula and you're solving for the piece on the left. If you have side, that means you're solving for one of these angles, which very clearly you can see in this formula, these angles are mixed in. So we're going to have to manipulate these formulas. I'm going to show you mathematically how to manipulate them because you really only need to memorize one of these and you should be able to figure out the others. If you want to memorize these three and the three manipulated ones, that's fine. But it's probably easier to just memorize one of these and then learn how to manipulate it. Now, I can't get from this one to this one. The only thing I can really tell you that's helpful is, like, you got A squared equals B squared plus C squared. It's always minus 2, whatever these two letters are, and then the cosine of whatever side length we're solving for. So, basically, it starts and ends with the same letter. The other letters are the other two letters. I mean, it's kind of the easiest way. But that's why I said these formulas are harder, but the actual principle of doing it, I think, is easier. Now, the other thing is, as we solve law of cosines problems, we usually only have to use law of cosines once. With law of sines, we were using it over and over again to keep solving for more pieces. Once we solve the initial law of cosines part, most of the time we switch to law of sines to solve it, like to solve for a side or an angle, because it will make it easier.
Wow.
But you can keep using law of cosines, it's just mathematically a little bit harder, so most people want to switch just to use the formula, because the formula applies. It's just we can't start out using that unless it meets those initial requirements we had the other day. So I'm going to manipulate one of these ones. I'm just going to start out with the top one. So a squared equals b squared plus c squared minus 2bc cosine A. And I'm going to solve for angle A. So in one step, I'm going to move over b squared and c squared. So I'm going to subtract those things. So a squared minus b squared minus c squared equals negative 2bc cosine A. Now all of this is being multiplied, so I'm going to divide by negative 2bc. So I've got a squared minus b squared minus c squared divided by negative 2bc equals the cosine of A.
So we're trying to find big A right now?
Yes.
Okay.
So rewrite it.
Now from 13.4, how do I undo this?
Inverse tangent of cosine.
Inverse
cosine.
Not inverse tangent, inverse cosine. So
I don't know.
angle A is the inverse cosine of all of this in parentheses, a squared minus b squared minus c squared over negative 2bc. So when you type this in, I would use the fraction button. If you don't have that, you've got to make sure you use parentheses when you type this in, or you're going to end up getting the wrong answer, or you got to work piece by piece.
What's the fraction button again?
Alpha y equals.
Alpha y equals.
Dang it. It's like the one button I don't have.
So this is to solve for angle A. Now, to do the other ones, I can kind of just follow suit here, right? So I know that whatever the letter is that I have, so this is if you're given the side case, you need this formula to solve it. So that would imply then that to find angle B, it would be the inverse cosine of b squared, because that's the piece that I started with, minus the other two sides, so minus a squared minus c squared, over
Oh, we don't have any.
negative 2, and then these two sides that are the ones that were being subtracted, so negative 2ac. And that would be how to solve for angle B. Okay, now the process would work the same as this one. I'm just not redoing it for the sake of time. So this would be solving for angle B. If I was solving for angle C, it would be the inverse cosine of this side length, the side length that goes with the angle, so c squared, minus the other two side lengths, so a squared minus b squared, over negative 2, and then these two side lengths that I'm subtracting off, so times a times b. And this would be how to solve for angle C.
Oh, I need to write
So you can either memorize all 6 of these formulas, or you can memorize one and know how to manipulate to find the angle ones, or you can, and I mean really as long as you know how it's set up and what they look like, you don't really have to memorize more than one, and then you should be able to figure it out from there. But it's up to you. They're all there. Usually on the quiz, what I let you do is I'll let you write law of cosines and law of sines and like the top of your paper and bring it up to me, and I'll check and make sure your formulas are right, because I would hate for you to do a whole problem with the wrong formula. Sometimes they're for extra credit. Sometimes it's actually a question, and that'll determine if you earn points on your quiz or not.
What was that? What did you give me? What did you just give me?
Okay.
What was in that? What happened to the government?
The other thing, just so that you have all your notes together here, is Heron's area formula.
I thought that was that's a bird, right?
Yeah.
What about a bird? The boy was
I've never watched the boy man.
That really sounds dumb.
All right, so the other day we had an area formula that went with law of sine stuff. This area formula is the area of a triangle with side lengths A, B, and C. So area equals the square root of S times S minus A times S minus B times S minus C. And you're probably like, well, what in the world is S? Because you didn't tell us S. S is 1/2 A plus B plus C. So we add all the side lengths together, cut it in half, and that's S. And then that's what gets plugged into that area formula.
Jeez.
The variable S is called the semi-perimeter or half perimeter of the triangle. So in addition to writing the law of sines and law of cosines, I also will allow you to write the area formulas, and I'll check those for you also on your quiz. Okay, so that way, you make sure you're using the right formulas. Some people only write the actual area formula, and they don't write what S is equal to, and they end up viewing S wrong. I'm not going to give it to you if you don't write it, but if you write S and you have it wrong, I will fix it. Okay? And that's going to work for all the formulas. If you only write one of the law of cosine formulas because you're like, I've got it down, I know how to manipulate it, whatever, I'm only going to check that one. I'm not just going to be like, oh, you wrote one, let me give you the other 5. Like, I'm not doing that. But anything you have in front of you, I will check for you.
What's the area formula for the? Oh, it's not. It wasn't in the notes. Okay.
It's area.
In the last section, yeah, we had to add it.
Yeah. Okay. Thank you. I was just
Right.
looking
Since
for-
I don't have a notes video for this, I'm going to stop this really quick so that I